All right, hey guys, I am back with another database Garnet vlog video understanding. I don't know what this is. Um, but anyway, I'm just gonna jump right into it. Uh, I found a pretty cool bug at work today, and uh, it sort of flipped a switch in my head about how I think about durability. Uh, Particularly because everything that I build on my own time can handle data loss. What that means is, let's say I'm doing 10,000 transactions a second, and if I lose, like there's a outage of some sort, and the VM goes down or my server goes down at home, and it comes back up, and I've lost 1,000, 10,000, like 5 seconds worth of data or something, I'm fine with it. Everything I build is meant to handle that. But the way we use Garnet at work is we use it as a strongly durable database. Now, Garnet is similar to Redis. It was, in its base nature, it does not provide those durability guarantees because it gives you the knobs to essentially configure that. And the way this durability is built is through two main phases. One's called the checkpointing phase, one's called the AOF. Now, they're sort of decoupled, but also coupled, and I'll get that in a way. The focus of this video is going to be on the AOF, but I can't talk about AOF and not mention checkpointing. So let's start with the AOF. What the AOF essentially is, and the way it's set up in Garnet, is it's a write back log, and it's an operations log. So what it will do is, let's say if I send set uh, key and val is the, let's just do k1 and v1. So I'm making a key value set request. What Garnet does is, uh, with the AOF enabled, what it's going to do is the very first thing it's going to do is process this actual command, right? So we can just black box that for now. We can say process the command. Then it's going to say, hey, append set k1 v1 into a file. And then it's going to return to the return. Okay. Now, this portion where once we create an append command into this file, first of all, this file itself and the whole mechanism of it being append only is what the append only file is. There's a slight gap between saying I've added something and knowing that it's been durably committed to disk, right? If I care about data integrity in the sense of durability, uh, it's sort of a spectrum, right? I can be the guy who doesn't care if I have the last 10 seconds worth of data or 30 minutes of data, and I can purely play off of the checkpointing mechanism, which is just calling save and your entire database's current in-memory state is just dumped into a file and you can load that up to go to a point in time. I could be someone who's like that. I could be someone who does not care about durability at all, like strong durability. Or I could be at the absolute end of the spectrum where, actually, before you go to the end of the spectrum, there's a middle ground where we're fine with majority of like losing some of the data. What that means is when I say append and before it goes to fsync into onto your disk, I'm fine if I lose something in that little gap. Or you could be at the absolute extreme of the spectrum, which is where wait for ACK that this data has been truly committed to the disk, right? What this means is when I restart the process, if something dies over here, I will always see data that has been committed. And this process can be configured in Garnet via the wait for commit. So let me add that over here. Wait for commit. This process of, appending all of the incoming ops is done by enable AOF. Now, with these two commands set, what is happening is every single incoming transaction is going into an append-only file. Now, that file is going to keep on growing, right? You need a way to shrink it somehow, and that's where the checkpointing comes in. What checkpointing does is it takes a point-in-time snapshot. There's other kind of checkpoints, but I only know the snapshot checkpointing, so I'm only going to stick with that. And what it does is it just dumps everything that's in memory into a file that's just key value, key value, key value all the way to the end. And there's some nuances to that, but I'll skip it for now. But it's just, you can think of it as mental models, key value, file. And once it's done with that, it says, cool, everything that this AOF signified has now been written into a separate file. So this AOF is really just redundant. So truncate, get rid of this whole AOF and restart building a new AOF. So you essentially switch out to a new AOF. The way it's done in code is, this is the AOF, it shrinks it, and then it goes this way. And when I say something's going that way, I mean the logical address is moving forward. Uh, but that's how the checkpoint is used to sort of truncate the AOF and still retain the data. Um, you could also just manually truncate AOF. You get sort of those commands in Garnet by default. You can tune it however you want. But for like extremely like strongly, consistently durable data, enable AOF, wait for commit. Um, and we'll go into the code in just a second. But I actually want to talk about how this wait for commit stuff works and how the AOF is actually working. What the AOF is doing is it's actually maintaining what I call in my head a data block or data record, data slash op record, and a control block slash commit block. Write log. Let me open this up over here real quick. NQ and command F try NQ. Cool. So this is your call to add something into the AOF. And this is one to call commit. Let's go look at that. All right, you know what? It's going to be inside of here because it's going to say fast commit. And in flight, yep, if auto commit. Commit. And what does commit do? Cool. Here is your commit code getting called. And there's actually two separate places where we're maintaining commits. We have the idea of a commit manager and we have the idea of the commit block on the AOF. We're going to skip over the commit manager because that's its own thing. Well, it's not its own thing. Think of it, the commit manager, as just a separate class that is handling writing files uh, for each commits metadata. And what is the commit metadata? It is this stuff, write log recovery info. Each commit tells you what the begin address at that point in time is, what the until address is. There's a commit cookie, there's a commit number, and all this data also has a checksum that you use. We don't need to discuss the checksum yet, but we will discuss the checksum soon. Let me go back. Cool. Now, what is happening on each NQ when we have the auto commit on is that after you add record 1, it's adding a commit block with the data that we just discussed. Let me actually just make sure that is indeed the data that's adding. Yep, try NQ commit record. Here is the write log recovery info, the one that we were just looking at. And you see that it's just mem copying it in there. Cool. Now, in this strong durability mode, RESP server session, wait for AOF blocking. Oh my God, look at this. 1 year ago, August 6, 2024. Crazy. Right over here. What we have is when you set the AOF wait for commit, before we tell a user, okay, we block for this commit block to be written to disk or something that says, hey, here's a strong durability barrier that you've crossed. What that means is that this entire commit needs to be written to disk. And only if, this is how we used to do in math classes, if and only if a commit block was successfully synced, do we write back to the user this acknowledgement, right? And this acknowledgement can be whatever the transaction's response is, right? So for a set, I think it's just okay. Or let's say if I said incur, it would send an int back of some sort. But it's an acknowledgement, and that's the overall concept. Now, what happens when I shut down my server for or it restarts? There's 100 reasons why you would restart the process, right? What would happen is your first of all, you use a checkpoint to load some of your data back into memory, and then anything that was not on the checkpoint is actually on the AOF, and you need to replay this AOF. But there's some metadata you need to find for that AOF first, and the way we set up this metadata is we say, cool, let me go find the last block. Actually, first, before I go to the last block, I look at the log commit manager. So let's start looking at, let me pull up my other code base over here. I'm going to dive into some more code. Where is this guy? Is it an AF processor? Is it a store wrapper? Replay AOF. Command F, replay. Ha, found it. Store wrapper. And we're going to look at recover ASIC. Cool. So now what's happening is at the time of recovery, you call some code path's going to call recover async. And like I said, first recovers the checkpoint and then says, hey, do we have an AOF on disk? Can we please figure out what is the start address and what is the end address that I can use to then go ahead and replay these records on the AOF? And as a part of that, we need to go ahead and use this guy, recover async, recover async. Give me a second, I'm going to find it on the other side. AOF processor, subwrite log. Is there recover in here? AOF processor. Maybe it's in Garnet log. Aha. Single log recover async. And what is a single log? Single log is a single log and recover async, which calls log.recover, which is subwrite log. And then in here we have recover. Boom. This is our recover call. Yep, I had a marker in here. I should have used that. What does the recover call do? First of all, we did not add anything over here, so this just gets a -1 during recovery. We go into this guy, restore latest, and first we ask the log commit manager, hey, what is the last commit that you have, right? And that gives us the info, which is also just the recovery info. And you get the until address. And this is a special mode that we're actually looking into, where remember how I said there's the logs that are in the AOF itself? That's only true if it's in fast commit mode. And in fast commit mode, what you do is not only do you write stuff to the commit manager, you also write stuff to the AOF, but at different cadences. You you don't want to do double the IO every time. So what you do is you throttle the amount of writes that you do into the commit manager, since those are all going to be a full file that you're writing every time, versus this is something that's already optimized. Uh, this is just writing, into the AOF as any other transaction does. What we do is at the restore point, we use the commit manager to figure out, hey, where to start from. And then if we're in the fast commit mode, which we are when we're building uh, a strongly durable, consistent Garnet instance, and we want it to be such that uh, the commit mode's fast. Use fast commit mode. Genius. What we have over here is this guy, fast commit mode. Scan forward for commit, and uh, let me go ahead and Command Shift E. Let me switch my C# solution because it won't let me actually go inside of this code right now. Savwrite.slnx, that's the storage engine. I really don't like working on my Mac for anything C#. I really, really just dislike it, but give me a second, guys. Switch solution. Ha! Cool, now that we've switched solution, my Control-Shift-Enters are they working? Okay, I'm just gonna head off a build. Savwrite. Come on, why are you not working? Command Shift B, .NET, build. Okay, I'm having some issues where apparently the right SDK is not there for this stuff, but that's fine. We don't need it. What we need to focus on is this guy right here. Scan forward for commit. And what this guy does is essentially inside this guy, Savwrite log solution file, go away. Okay. What this does is it's going to do a full scan on everything after the last commit manager's commit. And what it's looking for is what was the last durably committed data that told us the size and Savwrite log recovery info. Initialize. The last begin address, the last until address, essentially the metadata that is needed to manage the AOF that's already on the disk. And the way it does that is as it's going through the AOF, it sees scan forward for commit. Jeez, let me go back to this. Yeah, as it does that, it ignores everything that's on a commit record, keeps moving forward, and keeps on mutating this info field. Okay. Now, this is where things get interesting. The way Savwrite and Garnet is preventing partial writes, right? Because you see that they're already saying that, hey, we know incomplete entries can happen. But the way they prevent that, or the way they detect that, is this guy. Checksums. Okay? Every compute block has a checksum where it takes the first thing it writes, the second thing it writes, third thing, blah, 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 and it says, hey, this is incorrect. Or, sorry, hey, this is the expected value that you should get, and here's the value that was gotten. Now, one thing I want to show is that when this guy is called, yep. So each commit block has its checksum that was written at the time of writing. And at the time of reading, now we are doing a check against what we wrote and what we see in the state now. So you see over here, we first pull in the checksum that is expected, right? Then we pull in the expected begin address, blah, 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 just the stuff, right? And then over here, we say, hey, computer checksum for the stuff you just read. Does that match the checksum that was initially written? And if not, throw an exception. And what happens on the savewrite log scan iterator is the last guy to throw this exception gets caught. But the previous valid info is what is used to then go ahead and do a replay. So let's go look at savewrite log. Replay is not going to be here. Replay might also not be here. Okay. Replay AOF. Replay database AOF. This would be in database manager base. Command F replay database AOF. AOF processor. Replay. I've forgotten how to type. Where did it go? Oh, jeez. Okay, it's fine. We'll find it in a second. Uh, let's see. Do I have it on my other IDE that's open here? There it is. Store wrapper. So I basically work with a separate fork of this code base at work, and there's been a huge refactor done by the MSR team. Thank you, MSR team. But what that's done is now when I work on the open source stuff, sometimes I lose, like I'm using references from my work, which are on a separate code base, and not everything's one-to-one. So it's been hard to like navigate this a little bit. But okay, never mind. So coming back to this, what this guy did is it found the last valid info, right? And it set the addresses, right, based on that info. Now, when we start doing the replay, what happens is we use the we're just iterating over the savewrite log. That's it, right? Savewrite iterator. I think this guy's it. Get next. Let me just close some of the stuff. Okay. Get next. Get next. Where are you? Not this one. This one. Nope. Not this one. Not this one. Not this one. Let's use this one. This is the one that is used in the AOF replay phase. Now, what happens is now that we're going through the AOF again, this is the second pass, and this is where we're actually doing the replay operations, right? We've recovered using the metadata, now we're doing a replay. That AOF still has commit records, and when it comes across commit records, we do a check. And this is the same check, but this is where we have a bug. Any partial write on the disk would actually throw an exception here, but we don't expect an exception to happen here. This is the replay path. Why are we reading something that might have been partially written? So the responsibility to handle exceptions is actually in the recovery phase. And that is broken. And that is broken because when we're doing scan forward for commit, right over here in this initialize method that I was just in here for, we have an issue where we first assign the state and then we do the validation. So let's say this thing does throw an exception. We've already mutated the info object. And what that looks like is at the AF replay phase, we would run into this checksum issue. Now, why was this bug something that like particularly stood out for me, right? Is when I think about the AOF and outside of building databases, I've always thought that cool, if I ever had to write the AOF, I'm sure there's some amount of atomicity that I could get out where if I write a certain amount of data to disk, it is always written. I cannot have a partial failure. Uh, I know that disks come with like capacitors to handle power issues and this and that, but uh, having seen this happen in production, what I was able to do is I pulled out the AOF files and I scanned through the records, and I was able to find a commit block at the very tail, which was just partially written. It was missing all of the data at the commit number. It had this, this, this. It did not have any of this. And in such an exception, what you're going to see is you have broken all understandings of like my previous understanding of I thought that if things are sector aligned, if you're writing in sector sizes, it's going to be durable and consistent and all atomic. And while the durability thing is true, consistency thing is true, instead of trying to make a unit atomic, you need to flip the script on handling partial writes. And that was what sort of changed it for me, where I thought this was a pretty neat way to do things, where you detect the last commit block, and it's okay if it's partial. You had the commit checksum. Uh, this surfaced the bug. It's actually pretty easy to fix, and I'll make the fix offline because I don't want to keep people on a call while I'm doing this. But all of these just need to be moved down to post validation. That's it. It's that simple. And suddenly you can handle partial writes. Um, Again, like why did I make this video? Why did I go 25 minutes in depth about this? I think this is a great example of what happens if you just change the problem statement. I wanted to write my own write ahead log for something else. And I was sure that the way to build it correctly was to aim for some sort of atomic unit to write with. But, uh, one is how do you handle things being more than your sector size? Well, this actually handles that. Having checksums handles that. And I don't think I would have actually been able to learn this had it not been for the bug, me going down the investigation path and finding this. Um, I looked further, and this is actually the common way almost all databases are handling their write-ahead log uh, partial write or torn write handling. And yeah, I'm just going to make this a video for my own understanding so I can, look back on this and remember when I had that light switch moment. But that's it. Have a good one, guys.